can load an image similar to Word. You can just like go there, click file, load image. Then you can analyze the image on the tabs using the tabs, like you can go and you can even do pre-processing using the processing tools, like you can even do the band pass filter, those kind of filtering. And then you can also analyze using the analyze function. You can get the area, size. The only thing you have to do is you have to calibrate your image. As Dr. Jayas told, you have to just take an image of a 25 cents coin or coin, then you have to just measure the length of that coin and put that one as a length, and the unit, if you put it in mm, then your results will be shown as mm in your image J software. That's a basic software you can use. That's a free download. That's an open source software. You can download freely and you can use it. But that one doesn't give much comfort as like MATLAB do. Like MATLAB, you can do the image processing, also you can do the analysis, and you can also create your classifiers, and you can even do artificial neural network also with the MATLAB. So MATLAB is nothing but the mathematics laboratory. So they have like lots of functions available. So here we have to write the code, but it's not like writing the code. They already have the functions built in with the MATLAB. The thing you have to write the particular function and how to call the function and how properly calling that function. That's the important one. So the learning MATLAB, you can even learn by yourself. Once you go to the help and you can go to the function browser, you can get all those, like what are all the toolbox they have, they listed here. So if you go to the image processing toolbox, here you can see the tools available and image analysis and statistics, image arithmetic, image enhancement. So you can see all those functions over here. So if you go to image analysis, you can click like image analysis. So there is lots of functions available. So for example, if you want to the texture analysis, gray level, core matrix, if you click this one, it will show like what the function call, how to call the function, and what are the things it's calculating. So you can read by yourself and you can write your own code. Another way, like the MATLAB, if you go to the mathworks.com, they have the blog or community. So you can even get codes from the mathworks.com itself. So there is no need to write your own code. For example, if you want to analyze your image and if you want to do LDA classifier, there is codes available, but the only thing you have to know what they have written. So if you know the concept, then only you know like what that line means or what they are calling for. Most of the like all those programs, it contains I and J, like calling ij. So they have the matrix, they are calling the matrix I and j unit of the matrix, those kind of thing. You have to know what they are calling for and what that function do. So those are the main thing we have to learn from the MATLAB. Today I am going to just run through an example in the MATLAB tutorial itself. It's an image containing 50 rice grains. So now we can see about like how to get the image and how to remove the background, then how to count number of objects in the image, then we can see about like how to calculate area of one rice, and also we can also see about how to draw a histogram of that rice. So all the one like I am going to go through now, it's in the help topic itself. If you go through the demos, it has all those demos. You can they even have the videos. You can see through the video and you can learn. So if you go to the image processing toolbox, there is some examples available. So the first one is reading and writing images. Second one is the analyzing the image. This is what we are going to do today. So it has the image and how we are going to analyze the image. So they have like step by step code for this one. So the fourth step, they are subtracting the background from your original image, then increasing the contrast and threshold the image. This is the threshold, like segmentation of image from your background, how to threshold. Then identify number of object in the image, examine one object, just like one rice we are going to examine, and then how to label all those images, compute area of each object, and compute area based statistics. So what is the minimum area, what is the maximum area in the whole one, and we can get the smallest grain and the histogram of our area. So these are all the main thing we are going to do now. So the image is already stored in MATLAB folder. So the image, the file name is rice.png. So for even before, like if you want the CLC screen, it used to clear, CLC command used to clear your screen. Then now if you want to get an image, so now we are going to have our image in a I, that's the matrix name. So now we can call the, so imread, that's the command used to read our image. Then just give the file name with the extension. So whether it's a PNG file or JPG file or TIFF file with the so this is the matrix, like you can see all those ones, this is the matrix. So if you, this is the I, it's a 250 by 250 by 256 by 256 image, and these are all the grayscale value in that image, like each pixel. So if you want to see the image, then we can use the command called imshow. To see an image, like image show, that so this is the image we have now. This is the rice, background is black, but it's not like distinguishable. Some places it's like gray, some places it's black. So now we want to increase the contrast. So the next step will be getting the, like we are opening the morphological opening to estimate the background. So for that one we are creating a false image for our background. So we are creating a image called like background with our disk value as 15. So like disk value is the disk size you are putting in. We are having like 15, that's the diameter of the disk, and we are putting like black value for our background. So this is the, now we are creating a, so now we are creating a disk for the background. So now we have a background that's also 250, the same size as our image, and here you can see the minimum gray level is 40 and maximum is 98 for the background, and for our image minimum grayscale is 40 and maximum is 204. And third step, we are now going to view the background as a surface. So now we are going to create a surface for our background. So we are going to have the surface and we are going to use the background 1:8 to the n. This is the, like we are going to give the values from 0 to 255. Normally we use grayscale value between 0 to 225 if it's a grayscale image, every pixel has a grayscale value between 0 to 255, and if it's a binary image, it will be 0 and 1. 0 belongs to black and 1 belongs to white. Here it's 0 belongs to black and 255 is like pure white. So now we create a surface for our background. We can see it in like 3D image, how the background look like. Then we are setting the grayscale values. And then now we have the background and our original image. Now we can subtract background from our image to get our object itself. So this one, like once you subtract the background image from your original image, whatever you are getting, that's going to be the object image. So here the background is the background image, and I is the matrix containing data about our original image. So we can create another matrix as our original image minus background. So if you put a semicolon in, then you won't see any of your data in your command screen. If you leave without any semicolon, then you can see the grayscale value all in your command window. So now we create another matrix with our object itself. If you click this one, you can see the grayscale value of our object. This is original image minus background. So MATLAB is case sensitive, so you have to be careful on while you are giving the name or the matrix number. Here if you use capital I, you have to use capital I. If you use small I, then it will show the error. So if you want to see, like for example, like we already saw the image for I, if you just put like small I, then it will show because there is no file available in small I, so it's case sensitive, so we have to be careful on this one. Now we can see the segmented image. I2 is our segmented image. So this one is the segmented image. Now you can compare both. This is the original one. So now we just like the background, we put like more, we created a disk and we created the morphological surface for the background. So now background is like more distinguishable from our object. We can again increase the contrast between our object, because here also some places there may be some places the object belongs to the background, or background maybe belongs to the like our object. So we can, once we increase the contrast, it will be more distinguishable. So whenever we get data from our object, there won't be anything from our background coming into our features. So the next step, we can increase the contrast. So we can use the ImAdjust, that's the command used to increase or adjust your image to increase the contrast. So now again we are creating another matrix. So in MATLAB, all the data what we are giving or what we are inputting, it's all saved in a matrix or vector. So now again we are creating another matrix or another image with the adjustment. So now we are adjusting the I2, that's the, so whenever you are typing, you can see the options available. So you can, here you can just put the images, then it automatically uses the value between like min and max, by which it can adjust the contrast, or otherwise if you want to determine your lowest intensity and highest intensity, you can even give those ones. So you can use images, then your image name, then you can put the lower intensity, higher intensity, what's the lower intensity, like input, this is the input value, this is the output value. How much low you want as an input you have, and how you want low and out. So output, how much low intensity you want, high intensity you want. If you put those ones, you can get your image in that preferred, like whatever you are determining, you can get it into that range. So like all those commands, whenever you are typing, it will give the options. So if you want to run the default one, you can run it, or if you want to choose more specific for your need, you can choose whatever you want. So now we got the contrast, like increased contrast image. So if you want to see that one, we can. This is the new image we got. This is the, now you can see all the rise, it's all like white. So now we increase the contrast between our background and our object. Now our object is like, if you compare with this one, you can see all the rise. Now it's white. So we can tell this, all the pixels containing like white, we can consider this one as a object. So now we use the threshold. Now we increase the contrast, so our background is more distinguishable from our object. So we can threshold our image or segment our object from the background using the threshold command. Here we are using the gray value, like gray threshold value as our segmentation parameter. So the level we are deciding what the gray level we want to use as a threshold. So if you use the gray threshold value, then it will determine the threshold value we are using as a segmentation tool. Then we can use the black and white. We are making our image to black and white, and we are segmenting that one using the level as our scale. So we will go one by one. So now we are finding out what the level for our threshold. So now we have the level, then we can do the so now you can see the black and white, that's the logical one, and level. Now the threshold level of that image is like 0.4843. So now all the values is like between 0 and 1. Now it's using the value 0.48 as a thresholding value to threshold background from our image. So if you look this one, it's all like 0 and 1. So zeros belong to background and 1 belongs to our image. like our objects. So now we are going to make the black and white, like the image as our, like we are going to put all the values back into our objects. Then if you want to see the so this is the segmented image. So now we get the background as all zeros, and now we have value for our object. So using, now we can see the clearly, we can see the rice grains and the background separately. So now we segmented our image from the background. From this one we can obtain all the features, like what are the features we want. We can even like obtain length or size, like major axis length, minor axis length for each and every rice kernels. So the next one, we can identify how many number of objects in our image. So now we have, like, we don't know how many rice kernels in here, so we are going to count how many of rice kernels in this one using the command like black and white. We are going to use the connectivity, how like connectivity, the one like what we talk about, like how the 4 pixels are connected on. We are using the 4 pixel connectivity to calculate, to decide whether it's belong to the image or background. So now we are using the 4 connectivity, and the image size is 256 by 256, and here the number of objects is like 95. So this is the value. So we have totally 95 objects in our image. So even if you click like cc.num object, it will give how many number of objects in your . So now we have 95 objects in our image. So it means like number of rice kernels or number of white pixels has the 4 connectivity is like 95. So we can't clearly say it's all 95 belongs to our rice image or not. So we are using the 4 connectivity. So like 4 pixels are connected continuously, then we decide that one belongs to rice. So we use the concept to segment the rice kernel from the background. So here we get an answer like we have 95 kernels in there. So if you want to examine one of those parameters, so you can even use, like here we are checking the 5th element, like 5th object. Totally we have 95. If you want to examine one of those objects, now we have to create a false image. So we create a grain image that's so it's like false size of black and white image. We are creating a grain, and then we are going to use the, so totally we have like 95. Here we are going to choose the 50th one. So if it 50th one is true, then it will give the, it will store as a grain. So we are going to same size, like the image size will be like 250 by 256, but we are going to take only the 50th element. So we can change the number. If you want to get like 25th element, we can even choose the 25 here. So if it's like the element number is 25, then that will only visible in our image once we run this command. Now we can see the image what's in the grind. So it's a
Reader.
Oops.
Green.
No, okay. We put it in common. Yeah, it's not a file, it's a matrix, so there is no need to. So those are all the small things you have to be careful, because if it's in a file or image like you are reading it, then you have to put it in the quotation. Now, like it's not a, it's already in our MATLAB, it's in our workspace, so you just have to put the name, like just put the grind, then we can get the image. So this is the 50th grind we get. So if you want to see, we can even
50 means I thought 50 grains.
no 50th grind. So now we have 95 grinds, and we are now going to examine the 50th grind, like 50th.
Reduced to 50.
No, like now if you want to see the 25th, if you want to see 25th, we can just like, so we can see like now we have like two, like 25 and 50. So we can increase that one, because like now we are including the same thing on the image. So if you want to put like more, if you want to see another grind also in your image, so you can put that number if you want to see the 5th element on your grind. So now you can see the 5th, 25th and 50th. And if you want to view all your objects, so we can label the image and we can see it in like like color grind. You can color each and every grind and we can see it in color. So we can label the matrix. So label matrix, that the command used to label our matrix. Our matrix is CC, so we are going to label that matrix. So we can see now we create a label LD. Then now we are going to put the RGB label for our image. So now we are going to create another matrix called RGB underscore label with the RGB labels are labeled to RGB, that's the command, and label ID is our matrix, and we are going to do the, now you can see the so now you can see all the rice grains labeled, or like it contains, like we can clearly see in different colors.
So actually all should have different colors, no?
Those ones, like we can put like different labels. Now we can put like,
No, why some of the colors they have same color, but some of
it's just labeling 1, 2, 3. It's just like labeling those kernels. It giving the number for those kernels like 1, 2, 3. So then it put the, like it just like put some colors in that one just to visualize.
But those colors are
They are different.
They are
different.
Okay.
So gray level, like if you look at the gray level, it might be 150, another one might be 140.
Yeah.
So I can't tell the difference.
All right.
So if now we can calculate the area, like we can extract the features of an object. So if you want to get the 50th element area, so now we are going to create a matrix for our grind data. So grind data is like each grind we are going to get like the region props, that CC is the matrix, and basic regions we are going to extract. So once we give this command, it will create a database. So it contains like 95 and it has the data. So now the basic data, it contains area, centroid and the bounding box. So these are all the basic, we asked only for basic features from our image. So we get the area, centroid and bounding box of each of those 95 rice kernels. So if you want to know what is the area of your 50th element or 50th kernel, you just type like grind data 50 dot area, then it will show the area in pixels. It's like 194 pixels. That's the area of our 50th grind. So if you want to convert this one to real numbers like a millimeter or like a micrometer, we have to go for the same thing. Like we have to take an image with the same imaging camera, like the whatever the camera you are using to take that image. You have to take an image of a standard objects. Like if you know the diameter of a coin, you have to take the image in the same setup. Don't change the height of the camera or anything, or zoom. You have to take it in the same setup what you take the image. Then you can measure the length or like the major axis length. Then you can with the MATLAB you can calculate the major axis length. Then you can say like that pixel, like if it's like 194 pixels equal to 1 mm, you can give that one. Then you can convert the pixel into your real value. So you have to do the calibration to get real numbers. What are all the data we are going to get through MATLAB is like pixels.
Can we get area for all the kernels with one command?
Yeah, we can, like now we have like, it's like grind data contains all the things. So you can, if you click this one, it has a structure, so like it's not a image. So if you want to get like area of your 30th one, so you can get like grind data. You can go, the grind data is the database containing all 95 elements basic data like the area, centroid and the bounding box. So now if you want to get like grind data, if you want, for example, if you want to know the area of like 10th grind, you can just like put 10 here, then you can click area. Then you can come to know the area. So this the data you can write it up in a like matrix, or you can download, you can output file as a Excel file. You can even write your output as Excel file. That will have 3 columns. First column will belongs to the area, second one belongs to the centroid, and third belongs to the bounding box. So you can get like, if you want to know the centroid, same thing like grind data.
Sir, if we miss any step, then we can follow next step, or it will show as
Pardon?
if we are doing a step, then another step,
Can we take a sheet of area of all place?
No, like here now you can even like the grind, because this step only we are calculating the area. Like grind data, here we get the basic parameters. So if you have this step, like why we are doing step by step, the first one, now we got the image into our MATLAB workspace, then like open, that's the, we are going to import the image into a matrix in our MATLAB. Then we are like a background is like not uniform. The second step what we did is like we make the background as uniform as possible to segment our element from the background. Then third step, we increase the contrast to get like more separation from the background from our image. Then third step, using the thresholding, we segmented the image from the background. Then we like what we did is like, then we create like each grain, like we calculate like how many grain in there. Then for each grain we created the database. The like you can even like without doing the like labeling the matrix. If you label the matrix, then only it knows, the MATLAB knows what element you are asking for, which grain you are asking the data for. That's why we are labeling. Once you label, then it will like label each of the grain with their number, like 1, 2, 3, it will like 95 numbers it will give. So from that one, the grain data, that region props, that's the region's properties. So basic properties, it's like each of those rice kernel is a region. So for that basic properties, it now converted into a database called grain data. From that one, we are seeing all the results.
Now the grain data, can you export all 95 into Excel sheet in one
Yes,
step?
yes, doctor. Yeah, we can do that one. So that one you have to go like a file import and file export command.
But
So
all these 95 kernel area, we can get it with one command, sir?
one command, yeah, you can get it like a file export. If you do this one grain data, it will go and store in your Excel.
So backend already this software calculate area.
Yeah, like already this one, like the grain data, this one contains the all your parameters. Yeah. Which one?
One cross one structure.
So now you can see this data like, so it contains So if you want to download, or if you want to convert that one into your Excel, you can usually file output mode to, you can write it out, file write command to write your write your matrix into your Excel file. So you can use XLS write. That's the command used to download your data into a XLS file. So XLS, that's the Excel format, you can write it out. and even you can read your, if you have the Excel file, read command. And if you want to create a histogram here, you need histogram. It's like 0 to 255. How many bins you want? So here we put as 20. So if you put like 20, then it will give like your histogram in like 20 columns, 20 bars. It will. You can increase that one. So then you want the histogram. You call the histogram. So now we want grain area. We want that's the matrix, and that's the image. And now we need to get n bins. That's the number of bins you want in your histogram. We missed a step. I think we didn't create a. Yeah, we missed the step. Like we didn't create. So now we missed the step. We didn't create the grain area. So now we just from grain data we just going to create a matrix with only the areas. That's grain data dot area. So it contains the grain data contains the like three vectors. One is areas, another one is centroid, and another one is the bounding box. Now we are just going to get only the areas into our matrix. Grain area. Then now we can repeat the steps. Now we can get the histograms. So this is the histogram, and here we can see in our matrix most of the baseline value falls around like 200. That's the glacial value. So we can even like label. If you want to label your figure, you can even give the title. So if you give title. Along with your figure, so it will even you can get the title for this figures. So here you can even like give title. So you can save the image as a JPG image or like a TIFF image. Then you can use it in your report or paper. You can use that one as your histogram image. So like that we can do like more like functions with MATLAB. All the functions, if you want to know, like you can just go to the help and the function browser. You can browse all kind of functions available. The functions is the program they already developed and keep it in the MATLAB database. It comes along with the MATLAB. So you can take out all those functions and you can do your processing. At the same time, if you want to create your own program, you can create your own program, then you can store your program as a function, then you can call that function and do your operation. There is no need to write your code again and again for the same operation. So you can create your own program file and convert that one into a function, MATLAB function file. If you store it as a function file, then you can just like call that function file and you can do the operations whenever you want. So there is no need to write program again and again to the same operation. Pardon? So once you write, like you have to go to the editor, like if you want to go, like you can open a new editor file, then you can write your code here, then you can save it as a .m file, then it will be a function file. So then you have to call that m file, and for m file you have to, whenever you are writing a function file, you have to write a line how you are going to call that m file also. If you want to just like here it says like that's the m file name, then you have to give the data or what you want to put in as a input parameters. You have to define those ones whenever you are writing that m file. Or even like if you don't want to do the m file, you can even store it as a function file. You can store it as a m file. That's the MATLAB program file. So you can go and run that function like a MATLAB file again and again for your operation.
Could you take them to the classifiers? Different classifiers are available in there. And,
yeah, you can like you can just like go there. You can go to the
image function. Yeah, so the logic toolbox is there, but
there's the toolbox available, so you can even you do this one like image processing toolbox. They have instrumentation and control. Instrument control. So the morphological operation says like how to do the like intensity and binary images and taking the element. So the fuzzy logic toolbox helps you to get, and you have to go to the statistical toolbar to get all those classifiers. So statistics toolbox, here they have like different visualization, so you can do the regression analysis, multivariate methods, and classification. You can do all the classification plots and classification models here. So discriminant analysis, you can do the discriminant like MHRD analysis, and the classification like LDA, QDA, you can use this discriminant functions. And naive bias, you can do the naive bias classification using this one. So you can do the naive bias function for that one. So what is the? So all those tools available, all the classifiers are available under the statistical toolbox. So you can, if you want to know like more about like classification, you can click each of those classification. Then there is like examples available. So you can use those ones. Try out on your own to learn more about like classification. You can do the LDA classification, QDA, and MHRD and naive bias, those kind of classification using this statistical toolbox. So now like this is the basic MATLAB. We have to use our workspace to give the command, and if you have like specific toolbox like the image processing toolbox or signal processing toolbox or statistical toolbox, they have like GUI tabs. So using those tabs itself, you can do your operations. So, but for that one, you have to buy the toolbox along with your MATLAB. So MATLAB, it comes up with like a different kind of toolbox. You have to choose which kind of toolbox you want for your operation. Whether you need like signal processing toolbox or the image processing toolbox or statistical toolbox. Commonly, it comes up with an option like signal processing and image processing. And if you want, you can add your statistical toolbox also. Those toolbox helps you to do with graphical user interface, but you can do all those work in your basic MATLAB itself. Yeah, but for that one you have to know what kind of function we have to call those ones. But if you have the toolbox, it will make your life easy. And like if you have like more like doubts, like even though you have errors, it's like we can go to the mathworks.com website, or like you can go to the mathworks.com, like Math Central, that's the blog. They have the examples as well as the live blog. It's an open blog. So if you want to upload one of your program, you can upload it, and you can, if you need help, you can ask someone to help to check your code, whether it has any error or not. Like there are lots of people helping out through that online blog. I think we can't connect this one to internet now.
No, because it's date.
So now, like if your computer has the internet on, you can just type like mathworks.com, then click the community tab. It will give the examples and also the blog and also the codes, like code sharing. They have a separate website for the code sharing. So people write the code, they will share their code with the other people, so you can download that code. But the only thing is like there's lots of codes available. They may just use like only the color variation or like the like morphological variation in their file, but you have to just add more or take out those you don't want on your code. So nowadays it's then it's the like it makes your life more easy to do all kind of analysis.
Yeah, when you have the digital kernels, right? I have understood that we can do. But if you have, for example, bread slice, in that I think it would be very difficult to distinguish between the background and these.
No, like the bread, what you can do is like your whole bread slice, if you take an image of your whole bread slice, there is no background in that one. Your whole bread slice will become your image. Then there is no need to segment your image. So there, based on your application, if you just want to know like the grain size or something, then you have to just like do the like eroding or like filling up application for based on your need. Like in our lab, like most of the time we take images of bulk kernels or in a petri dish. What we used to do, like we used to segment or we used to cut down in only the central portion, like 100 by 100 image to do the analysis to avoid the errors on the sides. Like if you have a petri dish, there may be some shade of the petri dish falling onto your brain. So to avoid those like edge effects, we will always like cut down in the middle portion. Then we use that sectioned image for our analysis.
So we can take the image and we can cut the
slice, like whatever slice you want. Like most of the time, if you go from the center, it will be like more representative of your image, because we can avoid all those edge effect and temperature effect, all those ones.
So once you have cropped your image, you would then load your image, and then it will do the analysis of that image.
So now you can just like crop the image, use that crop image as your input for your analysis, like feature extraction and analysis. So the MATLAB software, you can use it like it's like a high-end one, you can use it for all kind of operation. But if you are just like want to know the size of your kernels, or like if you want to know the like a grain size or those kind of area, those kind of length, breadth, those kind of thing, you can even use the image J. That's the like open software. It's a free to download, so you can even download it free. Then you can use it, and it's like more easy. It's a graphical user interface, so there is no need to write any codes or anything. It's similar to the Excel. You have to just like go on click.
If you want to get the degree of whiteness, for example, degree of whiteness.
Can you check it?
Image J?
Image J. Just take one picture and it's easy to download. Yesterday
Yeah,
I just installed on
I
this
showed
one
that.
PC.
Image J.
Image J.
Image, yeah, we can do it like, but this
Just
one,
take one picture and
like I'm not sure like whether it's allowed to download any software here or not.
Change कितनी है?
No, you take back, then you can
मैं कितना
download.
हूँ?
What is it called?
Easy हो गया.
Can we download images?
Yeah, he's coming, so he would make this internet.
Yeah.
Just extract it and
Yeah.
install.
One by one you can go and you can drink tea here, but don't throw the tea on the table and cup has to be, right? One by one you can, it will save the time. Go out and bring your tea here.
Yeah, at the same time, if you want to try like a MATLAB, you can try it on your, like I think some of those computer has like MATLAB, you can try it out, and if you have any doubts, like contact me.
Then it will save time.
Once you know the boundary construction, you say the image of the mountain, you will then load that image.
And you'll be taking it along the background only. There will be
No,
no background.
in that case, you have no background. So you will then you load that image, and then MATLAB, and then you ask if you don't have now to find the image, or you want to restore it,
Like we can increase the contrast, or we can get the codes out of the image.
So you can use the function
Just the
adjust the
contrast.
contrast. Once you have done that, then you can
So we don't need to segment the image, no?
no, because there is already all the full image is the image. There is no background.
So now
And then we
it's the
can
same thing.
calculate the number of objects at the same. So it will calculate the object will be the pose.
So that case, the function again, you use the function, which function we calculate, so you can say give me the
Same, right? But here, like the background is going to be like white. So you can like do the like white. Yeah, this one is this one like also contrast. Yeah, like once we increase the contrast, then maybe you can move the background to your area.
then drop those connected to users, and then it would count how many ports you have, or how uniform those ports are, so that each port will become an object with that kind.
Can we get the device and we can try it?
Alright, once you like import your file into the MATLAB, there is no need to do your